All right, here's our final video for lesson 7-11. Let's get into our math boxes. Let's look at number 1. Miss Hill's 3 dogs weigh 56, 62, and 65 pounds. Mr. Hoffman's 3 dogs weigh 67, 72, and 75 pounds. How much more than Mrs. Hill's dogs is the combined weight of Mr. Hoffman's dogs? So let's look at what they're asking us. They're asking us how much more is Mrs. Hill's dogs is the combined weight of Mr. Hoffman's dogs. So first, let's figure out what's the combined weight of Mr. Hoffman's dogs. So his dogs are 67, 72, and 75 pounds. So I'm going to add up all of those. So 5 plus 2 is 7, plus 7 is 14. 7 plus 7 is 14, plus 6 is 20, plus 1 is 214 pounds. So now we have to figure out how much does Mrs. Hill's dogs weigh. So this is Mr. H for Mr. Hoffman and Mrs. H for Mrs. Hoffman. And her dogs weigh 56 plus 62 plus 65. So 6 plus 2 is 8 plus 5 is 13. 5 plus 6 is 11, plus 6 again is 17, plus 1 is 18. So now we have to figure out the difference between the two dogs. So Mr. Hill's dogs are 214 pounds minus Mrs. Hill's dogs. So I know that 4 minus 3 is 1. I have to change this to an 11 and borrow from the hundreds place. 11 minus 8 is 3. And then 1 minus 1 is 0. So now I'm left with 31 pounds. But you have to be careful because look how the problem wants you to answer. It wants you to answer in ounces. So you have to take, so this was multi-stepped. Finding out how much all the dogs weigh is step 1. Step 2 was finding the difference between Mr. Hoffman and Miss Hill's dogs. And step 3 is converting that weight to ounces. So if there's 31 pounds times 16 ounces, 6 times 1 is 6. 6 times 3 is 18. You need the 0 placeholder because this 1 is actually a 10. 1 times 1 is 1. 1 times 3 is 3. Now we're going to add and we get 496. So the answer is 496 ounces. So this was a 3-step problem. Okay, let's look at number 2. Use the rule to complete the table. The rule is times 5. So 203 times 5 would give you 1,015. Now, you could either do what times 5 would give you 1,535, or you could do 1,535 divided by 5, which would give you 307. You can use partial product for all the division. 422 times 5 will give you 2,110. 2,590 divided by 5 will give you 518. 613 times 5 would give you 3,065. Okay, let's look at number 3. It is 7/8 mile from Anne's house to Emma's. On her way, Emma stopped at the store, which is 3/8 mile from Anne's house. How much farther did Emma have to walk? Okay, so let's read that again. So we know that it takes from Anne's house to Emma's is 7/8 mile. So on her way home, Emma stopped at the store, which is 3/8 mile from Anne's. How much farther did Emma have to walk? So you would do 7/8 minus 3/8, which would give you 4/8. Okay, more division. So I'm going to do one with partial product and one with traditional long division. So I'm going to do my line for partial product. I know that 9 times 100 is close to 836, but it's too big. So let's do 9 times 90, because I can do that in my head, because I know 9 times 9 is 81. So 9 times 90 must be 810. So now I'm going to subtract, and I get 6 minus 0 is 6, 3 minus 1 is 2, 8 minus 8 is 26. Now I know that 9 times 3 is 27, which is close, but it's too big. So now I know that I'm going to have a remainder, because 26 is not a multiple of 9. So 9 times 2 is the closest multiple that I can get. So 9 times 2, which is 18. And if I subtracted 26 minus 18, I would be left with 8 as my remainder. So my answer is 92 with a remainder of 8. Okay, let's do B, but we're going to use traditional division. Oh, I'm sorry, I didn't need that line. Okay. Does 7 go into 6? No, because 7 is too big. So now you have to go to the next place value, which would make this number 65. So I know that 65 is not a multiple of 7, but 9 times 7 is 63, which would gets me pretty close. So I'm going to put a 9 over here above the 5 because we had to go to the tens place. And I'm going to put 63 because 9 times 7 is 63. 65 minus 63 is 2. And now I'm going to bring down this 2 to make it 22. Again, 22 is not a multiple of 7, but I can get close by doing 3 times 7, which would give me 21, and I'm left with a remainder of 1. Okay, number 5, writing and reasoning. Look at the outputs. So here are all the outputs of problem 2. What patterns do you see that are not part of the rule? Well, I know that the all of the numbers in the output box, they end, all numbers in output end in a 0 or 5. And I noticed that when the number in the input box was odd, the product, so that means the answer from what you multiplied, is also odd. So, for example, 203 is an odd number, and so is 1,115. Same thing here. 307 is an odd number, so is 1,535. Now wait, 422 is an even number, so that's not an odd number. So is 518. But 613 is an odd number, and the product is also odd.